This chart tracks a specific growth pattern in modern media. A YouTube channel named Zen reached 70,000 subscribers after uploading only 10 videos, a ratio that satisfies the requirements for immediate monetization. Historically, achieving this level of density in educational content required an entire team: a researcher to parse academic papers, a writer to structure the narrative, and an animator to visualize concepts. This diagram maps the process of channel cloning. By using AI to scrape a successful channel's library, it is possible to map its structural DNA and extract the logic behind its success. This workflow requires no background in software engineering. The entire process operates on zero code, utilizing software accessible through a standard web browser. By feeding that data into an automated pipeline, the system reassembles the elements into a complete digital property, ready for publication. The technical monopoly that once restricted independent creators from producing premium educational media has now been completely bypassed. The assembly begins with raw data collection. You select a reference channel and pull 3 to 5 screenshots, along with the text transcripts from 3 of their videos. That material is fed into Claude AI. By using its specialized coder mode and a structural master prompt, we provide the AI with a framework to interpret the channel's data. Claude produces a branding brief, analyzing the tone of the inputs to generate a new identity. For an ancient history channel, it might suggest a title like Lumizia. Next, we direct the AI to generate targeted episode topics. We can specify the target demographic, asking Claude to calibrate the vocabulary and framing for an Indonesian audience. From that list, we select a specific evolutionary topic, exploring why humans are the only animals that cook their food. This diagram shows the relationship between text volume and video length. We direct the AI to write a 2,000-word script, ensuring the video hits the 10-minute mark. This threshold allows multiple ad placements, satisfying the algorithm's preference for longer sessions. The language model acts as a multiplier. It takes a handful of transcripts and extrapolates them into a structured piece of intellectual property. Once the script is finalized, the pipeline shifts to vocal synthesis. The 2,000-word text is moved into Google AI Studio to generate the voiceover. To avoid a flat delivery, we select the patient-teacher acoustic template, which provides a more conversational tone. This diagram shows a specific technical adjustment. By setting the audio temperature to 1.15, the system introduces variance into the track, creating more natural pauses and inflections. For the visuals, the original reference screenshots are uploaded back into Claude AI. Claude translates those images into descriptive data, producing a sequence of 100 chronological image prompts based on our new script. The prompts are sent to an image generator. We set the ratio to 16:9, rendering the complete visual sequence. Final assembly happens on the timeline. We layer the voiceover with the batch-generated visuals and apply film frame effects to create a documentary aesthetic. A production process that previously required a specialized team has been converted into a data sequence moving between 3 tools. The final output is an atmospheric exploration of human evolution that mirrors the quality of high-end, traditionally produced content. While the final video carries the polish of a professional documentary, the production required no manual animation or specialized video editing skills. For this genre of content, the barrier created by expensive production skills has dropped. Detailed visuals can now be generated via a command line rather than years of technical training. The required skill set for this workflow is the ability to architect prompts and manage the flow of data through an automated pipeline. In this model, the human role changes from physical execution to system architecture. Instead of drawing the frames, you are managing the pipeline that produces them. As the tools for high-end production become accessible to anyone with a browser, the primary bottleneck shifts back to the quality of the initial premise.